Assalamu alaikum. Welcome back to my channel Automation Lab. Today eh, today present I will try to make a series of PLC programming on LS PLC, and next I will start on series of PLC programming on a Siemens PLC and Mitsubishi PLC, etc. I have this two type brand of PLC, Siemens PLC and LS PLC. First I introduce make this series of programming LS PLC, then next I try to I have this LS PLC. Today I show datasheet and software, and next tutorial I introduced terminal and indicators of this LS PLC. Then so you see here this is the datasheet of XBC DR32H D32S. Here we have seen that four type of CPU, XBC DR32S and XBC DN32S, and DR and DN indicates DR is relay output, 32 indicates 32 input output points. In this compact CPU have 32 input output points, 16 input points and 16 output points, input points and output points. 16 input points is DC, all input LS PLC and most of PLC brands, all are input signals is DC 24 volt most of case, and this mainly defined in output points. This output point will be transistor type or SSR or transistor type or relay type. In transistor type, for transistor type we can control only DC load for low ampere and low voltage. For relay output point we can control AC and DC. So I have this module. I have this DR32S. It is a DC DR32, and this is the brand of LS Industrial Company Limited. Then I show a specification of this PLC. Let's send it. Before system design and hardware wiring, you should clear this technical specification of all device. It's not for PLC. It is preferred for any input device, sensor, switch or output device. Now I try to clear technical specification of this PLC. I have this model of the PLC XBC DR32S. So for this XBC it will be 64. Another model is 64. Just difference 32 and more 32 input output. Here is DN and D64, and operation mode is the cyclic. We know that PLC is the industrial computer. It can take input signal from input device, and based on a custom programs it can control output device like relay, medic, contact. All are always scanning input. All PLC always scan the in programs, and based on this program it creates generate command signal. This is the mainly defined PLC is support defined programming language. Defined programming language according to IEC should be all PLC brand should be follow ladder diagram. So is the common ladder diagram programming language. Also this instruction list, also functional have programming language, but this LS PLC support only two languages, ladder diagrams and instruction list. Other PLC Siemens support functional block diagrams and instruction list, sequential flow chart, etc. And next I will discuss this. And then number of instruction, the basic instruction is 28 and application instruction 687. During programming, we introduce this basic instruction. This basic instruction will be NONC and relay coil, etc. And application instruction should be mathematical, PID, high-speed programming, counting systems, PID control systems, and communication instruction. So step by step I will discuss basic instruction, then application instruction, PID communication, etc. Is the most important when capacity, and its programming capacity, it's depend on CPU model. Another CPU is when the process system is large, you can use a large PLC as XGK, XGI, XGT for LS, and as like Siemens will be 1200, 1500, etc. This is this programming size and capacity will be vary depend on the model. For this PLC, we can make these programs up to 15 kilobyte kilo steps. This is when you calculate the speed of the scanning speed or execution speed, 83 nanosecond, so fast. 83 nanosecond per step it's take to time to required processing. Now is most important for digital maximum IO points. It's input output points. For this model, it's support 352 IO model. Input output points 352. This input points, physical input points, and also it's have different type of memory device, P device, M device. It's used in our programming, programming memory, auxiliary memory. K is the very important memory, is the EPROM memory. Is a state, it keeps status in during power failures. It's very important. And another is important, T memory, T device. T device indicates the timer. You know that the most of application, most usable device in logic systems is timer. It's make delay. There are 1023 maximum 1023 timer device available. You can hear T002, T1034, T002, T499. Its preset value is scale is 100 millisecond, 100 millisecond. T15 to T999, its resolution or scale 10 milliseconds. When set 1, it is during timer programming you will clear this. And this counter, it has 1023, 24, 1024 point counter. You can use especially you can use count number of counter based on your process or process systems. K device, U device for special for communication and analog operation use U device. And then operation mode, it's have three operation mode. Run mode, when process system is run, it can take in run mode, it can take receive input signal from input device and send output device. Stop modes is can't it's power up and stop modes during program download and upload. In a stop mode we can download and upload this program. Debug mode, we can PID communication, PID operation, we can use this debugging modes. And also I have mistake one, maybe it's mistake error mode. Error modes means when the PLC find out any error, show error modes. Number of programs 1 to 8. Number of program means it supports library function, and small programs is 128. Then it's important feature PID operation. It supports PID. It supports PID control function. Also CNET is special for Modbus communication. CNET is important. Modbus protocol support. It support Modbus protocol. Also positioning support, pulse cache, high speed counter. Also it support high speed counter. Now another important built-in CNET is here, built-in CNET, other function PLC, and IO allocation mode is important. In the this the main CPU is important. IO allocation, you here see this is the main unit. This is CPU, first unit, and all are expansion module. We can connect up to 10 expansion module. It will be digital expansion module, analog expansion module, communication module, depend on our requirements. We can connect expansion module. Also it support positioning. We can drive, servo drive and stepper motor for servo drive or stepper motor drive, and also support PID operation. Now built-in signal, it's important. Main unit support maximum its main unit support, just I say mark 64 points. I have 32 PLC, it's 32 input output points, but another model another model will be 64 input output points, fixed point. But when we cannot connect exceed 32 points, if you want to extend this input output point, need to be connect expansion module. First expansion module, if you use digital input output, this digital input is address will be start P00, first address input P00, and output address start P20, and input start P00. So it's important when programming. I write P00 is the input point, but how I can take information from the P00 is input. So P00 is start input address, and P20 start output. It's I think it's a mistake. Maximum PLC input and output variable address is different, as like Siemens use input I and output Q, Delta use input X, output Y. It's depend on it, but they are use LS PLC use for input and output same P device, P alphabet, but you should be careful. P00 after P the number of points address. Next here expansion module, maximum expansion module 10, analog expansion module is important. Analog expansion module mainly it will be input and output expansion module. You can connect analog expansion module here, AD converter, DA converter, RTD, thermocouple, etc. Just I introduce this data sheet. Today I introduce data sheet next, and I show this is the software of this LSP. This software is XZ5000, XBC DR32H XZ5000. Next tutorial I will discuss how create a project, programs for this PLC. Thank you. Assalamu alaikum warahmatullahi wabarakatuh.